right, hello again everybody. Welcome back to Airbus 320 Tech Talk. What do all those buttons do? Thank you again for joining me. I'm back home today on a day off, and we're going to continue our discussion where we left off last time. So the next area of the panel that we have to tackle is moving down from where we last left off. It is the fuel section here on the overhead panel. So what I wanted to do first to start this video off is just kind of give you guys some just some kind of basic high-level, conceptual things just about the fuel system itself. There's kind of a lot going on here, and this video will probably be a little bit longer today, so hope you can make it till the end. There's a lot of data, but thanks for your patience and your dedication if you do make it to the end. But so to start off with our discussion today, everything that we're going to be talking about in today's discussion topic here, and actually it pertains specifically to the Airbus 319 and 320, the domestic version. So we've actually got some minor differences between the 321 system first of all, and there's also like an ETOPS or overwater version of the 19 and 20 that are operated. So like I said, there are some systems differences between those various models, but we're just going to kind of keep it simple today, and everything we talk about is just going to be based strictly off the base model of the 320, like we said, for domestic non-overwater operations. So just keep that in mind. There's a whole lot more we could build on top of what we're going to talk about today, but it's just such a lengthy discussion that I wanted to try to keep it somewhat simple for you guys. So let's just start with like I said, the 320 itself. So first off, I mean, the very obvious answer, I mean, of course, like why do we have the fuel system is, to house this combustible liquid that we need to run the engines and the APU. But there's also a couple extra really interesting things that this fuel system does for us as part of the design of the aircraft that you may not have guessed about. So one of those things is the fuel system actually also provides cooling for the integrated drive generators. So there's actually a system on board the airplane that recirculates this cold fuel that resides out in the wing, during the course of a normal flight. I mean, as you'd imagine, the outside air temperatures keep things very, very cold, temperature-wise. So we can actually use this cooling. We circulate this fuel past the heat exchanger in the IDG there. That cools the IDG oil. So it's really kind of an interesting design and kind of a genius thing I think they incorporate into it, but once again, something you might not have guessed. And one other thing that's interesting about the 320 anyways is the way they've situated the tanks on the airplane. The fuel system actually provides for wing bending relief and some flutter reduction on the wing. So if we'll kind of build on this in a second here, but there's these outboard tanks, if you will, and actually I'll go ahead and bring up just one of the graphics here that we're going to talk about. But when you look at the synoptic page here, we've got these breakdowns of these segmentations in the fuel tanks themselves. So we have these two outboard sections here. We have the main sections of the wing. We have a center tank here, and these outboard sections actually maintain the quantity of fuel until kind of towards the latter end of the flight, which we'll talk about that a little bit more when this fuel transfers and when things kind of start to change. But if you think about it, this fuel situated out, towards the extremities of the wings kind of provides like a counter weight, if you will. So, as the plane is flying along, you kind of have all these forces that are flexing the wings, up and down, just as part of, once again, a normal flight and turbulence, all this kind of stuff. But these counterweights in the form of that fuel kind of residing out towards the edge of the wings kind of offsets those forces a little bit. So I think, once again, a really interesting design concept that they incorporated into the airplane. Let's see, the next couple things we'll talk about here are going to be still general. Right out of the book here, we have a breakdown, if you're curious about, well, how much fuel does this airplane actually hold? There's a whole bunch of different numbers here. But the main one I'm going to point out to you guys is the volume and the weight. And in our configuration that we operate at my company, we have this no ACT, means no additional center tank. So just the tanks that I've already outlined, what we've talked about so far. We can hold roughly about 6,400 gallons or about 42,000 pounds of weight. So just some numbers there, and kind of a gee whiz fact to kind of throw on top of it. There's one little reference in the book also that talks about if you needed to go from completely empty fuel tanks to filling it all the way up. It takes about 20 minutes with the single point fueling that the airplane uses, and we'll talk about that a little bit too, a little bit down the road, but just some numbers to throw at you there as far as the capacity of the airplane is concerned. And also a really interesting thing to point out also is that built into these numbers, the manufacturer has provided for a 2% gain or rise, let's say, in the quantity of fuel. And if you consider, atmospheric conditions actually do have an effect on the fuel, like the volume it takes up itself. So, basically as the fuel heats up, let's say the plane's sitting on a hot ramp or something like that, it actually expands. It's just a physics principle that, a liquid will expand when it heats up kind of thing. So they've built in this little 2% allowance for expansion in the system before you'll have any kind of venting over or spillage, if you will, which is also kind of part of the built-in functionality of the airplane. It's kind of interesting when you walk out underneath the wings, there's these little kind of relief valves that if it were to be, such a situation where the fuel is expanded too much or it's been overfilled or something, the fuel will actually vent out of the wings before it actually damages anything. So I think kind of a neat thing to make mention of there that you might not have been aware of. So along those lines, let's take a look at one of the other schematics that I pulled out of the book here. And this just kind of talks about everything I mentioned so far. The center tank here, the two inner main wing tanks fuel, the outer tanks, and then this little vent tank is kind of an area for this fuel to kind of spill out over onto. We don't really reference these vent tanks or much think about the fact that they're even there most of the time when we're flying around and we're operating, because it's just not part of our normal thing that we're concerned with, but it is there. And like we said, this ACT1 and ACT2, if you're curious about what that means, it's just additional center tank. That's all it means. So if the plane was designed, or a company had decided to order one with this feature on it, which would of course enhance the range and all this kind of stuff, these would be installed in the aircraft. That's what they're there for. And one other interesting thing to point out to you guys, we might have mentioned it in a prior discussion, but anytime in the Airbus manuals you see this little triangle with an asterisk in it, it actually just means it's an option that, not all the airplanes are outfitted with this, but just for the purposes of when they publish the manuals. So I think it's, a little bit less printing or something they've got to do. You'll see these types of things a lot of times, and you just need to kind of, just be aware that it's there. It doesn't, really, I guess, affect a whole lot, because obviously we know about the configuration of the airplane we're operating. But if you're curious about that, that's something it took me a little while to figure out. I had to go digging for it, but that's what these guys are here for. That's what they mean. So the next thing I want to talk about is just to give you a little bit more elaborate details on the types of pumps that we have on the airplane. So let's pull up our basic system display here once again and take a look at some of these things in a little more detail and talk about them. So in each wing we have two AC electric fuel pumps. So that's what these box symbols are right here. We have two also in the center tank. So these are, I guess, if you want to think about it, kind of the main way that we feed fuel under low pressure out to the engines. So we have these 6 AC fuel pumps on board the aircraft. And one other thing that it's not really outlined in this graphic, and it's really interesting, when you're running the APU without any of these fuel pumps on, the APU actually has its own low pressure fuel pump that can draw fuel out of the system. And like I said, it's interesting because you won't actually see anything different on this status page here other than this little green triangle, or excuse me, the triangle that is white right now, meaning the APU fuel pump is off. It will turn green. It'll just let you know that the APU fuel pump is actually functioning itself, and that's what's delivering the fuel pressure to the APU itself. So one little minor nuance, but that pump is there in the system. And there's another graphic that just kind of draws this stuff out a little bit more in a little bit more detail, but we won't go through every single one of these little portions of the graphic here, but you can just kind of digest it as we're talking about it. But here we have that APU fuel pump like we talked about. And one interesting thing to tell you about this APU fuel pump is that it can actually get power from a non-AC source. Now, this is interesting because the actual APU pump itself, it is an AC powered pump, but there's something called a static inverter, which actually allows DC power to be converted to AC power. In the case of, let's say, you show up to the airplane, there's no ground, jetway power hooked up to it, there's no power going to the thing at all. Well, just using the battery power alone, we need to have a way to get this APU online so we can establish AC power to the network of the airplane, and then we can power all these other pumps that rely on that AC power to use. So it's kind of just, once again, I think it's a really interesting design concept that you can get this pump running without any AC power on the airplane, if that makes sense. So just to draw that all together, the point is you can start the airplane with battery power only and get everything going that you need to do, and it kind of starts with this APU getting up and running and whatnot. So one little interesting thing to tell you about there. Some other interesting things to tell you about is these transfer pumps here that reside in the outer tanks that allow for fuel, like we said, when the time in the flight comes that, this is all like an automated, kind of pre-programmed thing that the plane figures out that it needs to transfer that fuel out of the outer tanks into the mains. There's these two transfer pumps on each side that are electrically powered that will open up. And this happens when each of the main tanks gets down to 1,650 pounds and the center tank is empty, which is of course our normal fuel feed schedule, if you will. We'll kind of talk about that a little bit more in a second, but just wanted to make mention, like I said, of these transfer pumps here. We also have a crossfeed valve here, and you can see it in this graphic here. We could pull it up on the status page once again. And that is just this little green guy in the middle here. And if you were to reach up and press the button and open the crossfeed, you would see these green lines kind of change their flow. You would see fuel flowing from one side into the other side's engine, and you would kind of see this graphic change a little bit. But that's just the purpose of this little round indication right here is that crossfeed valve. And to elaborate a little bit on the crossfeed valve, it's interesting because the crossfeed valve is not actually used to transfer fuel from one tank to another. All that we can really do with this crossfeed valve is get the opposite side engine to feed off the opposite side's tank. So another interesting thing to tell you is that we don't really have a way to transfer fuel left to right during the course of flight. This can actually be done on the ground during a refueling operation, interesting enough, but we can't do it in flight. So the best we can do to try to balance our fuel out if it gets imbalanced for any reason is to use that crossfeed valve. We just kind of watch it and you'll wait till the quantities become roughly equal again. And then you close the crossfeed valve and you kind of go on as normal throughout your flight. So the other one to talk about, interesting also, they're not actually depicted anywhere on this status display here, is that we actually have these suction valves in the wing tanks only that allow for fuel to gravity feed to the engines. If for some reason you had no pressure, no way of getting fuel through the pumps, or the electric pumps anyways, these suction valves will automatically open up if it detects a loss of fuel pumping pressure, and the plane will just keep on flying like normal. And it's pretty basic system that Mother Nature helps us to continue an uninterrupted flow of fuel out to the engines there. One other one to tell you about also to make mention of is so all these pumps that we've talked about up to this point, like we said, they're known as low pressure fuel valves, and these are meant to just basically route that fuel out to the engine itself. But once it gets to the engine, there's actually a high pressure fuel pump that's actually geared to the accessory box, and it spins when the engine's spinning, and it provides fuel under high pressure now into the actual inner workings of the engine where the combustion is taking place. So just one other thing to make mention of that it's kind of above and beyond what we're talking about today with our overhead panel and how we interact with it and everything we've covered up so far. But just to let you know that those are there, it's kind of interesting. One other thing that I wanted to outline also is just kind of the general fuel feed kind of programming that's built into the plane. So everything is all automated to begin with. So once again, we're not really thinking about this stuff when we're on the ground, taxiing out, taking off, progressing through the course of our flight. But the plane is actually designed that to facilitate for a couple things. So number one is you never will be taking off or landing feeding from the center tank. And kind of the idea with this is these are both, of course, critical phases of flight. And you want to have the, if something catastrophic were to fail, you don't want any interruption of that fuel flow to the engine. So therefore you have this kind of redundancy built into the main wing inner tanks, if you will. And so that's kind of the reason why we want to have this setup as it is. So there's all this system logic, and there's these different conditions that when they're met, the plane knows to like switch over to this feeding scenario. But once the plane gets up and going, it'll revert back. And the other concept that it's designed to do is that you'll always burn all the fuel out of the center tank first, and then once that's completely depleted down to zero, you'll switch out and you'll start burning the remainder of the fuel that's out in the wings there. And if you kind of think about this from an aerodynamic sense, it makes a lot of logical sense, of course, because think about the airplane, once again being on this like teeter-totter of a center of gravity as it's flying through the air. You just want to have the weight kind of distributed, kind of further out from the center of gravity because it provides stability, and it's just the way they designed it to work. And that's the way that a couple of those things are set up the way they are. So let's now move on and talk about some of the external components of the fueling system. So a little graphic here that just kind of shows some of the things that you would find in the outside of the plane. So once again, we see these asterisks, triangles here that tell us that some of these panels and these locations are just options. I've never seen any of the planes that we have, and I feel like most of the planes that are operated here in the United States kind of fall under the same category, but you only have the one single point refuel coupling on the right wing here, and you have the refuel panel kind of at the wing root here. I've never seen the setup where you've got two single points on both wings, or the additional panels for whatever reason they've decided they need to be there. But that's just kind of some basic things about the external refueling access points that we have. And I took a few pictures on a walk around the other day just to kind of give you a little bit more close-up look of what this single point fueling receptacle looks like here. It's just kind of towards the forward section of the wing. There's this little cap that screws off, and the fueler will just go up, and there's this little rotating kind of there's this metal piece that just kind of sits into this seating there that's got these little teeth on it basically that allows it to lock in, and the fuel can start flowing. And one thing also that's interesting to mention about this single point fueling and why we do it this way is because you actually get a lot more fuel into the airplane in a lot more expeditious of a fashion when you can deliver fuel under high pressure and pump it out into all the wings and kind of meter it out automatically really as to where it needs to end up at, then as opposed to earlier on in aviation you actually used to overwing fuel the airplanes. And it's interesting, if all else fails, you could actually walk up to most of these modern aircraft, and there is actually like a gas cap like still on the top portion of the wing that you just screw off, and you could walk up there with a hose just the same way you would with your car maybe at the gas station there, and you could you pull the trigger and you can just fill up however much you need into each wing. So kind of a contrasting system. You can kind of see why they've designed it this way, and the single point thing is it's just so much easier, it's quicker, and it makes a lot more sense, of course. And you have these constant operations, these planes coming in and out of these stations all day long, needing fuel in a timely manner, so to speak. So a little bit about the fuel receptacle there. I also took a picture for you guys on the outside of the airplane, the refueling panel itself, what the fueler would actually look at. So once again, we're kind of in the wing root here on the right side. And this is actually a panel that you don't need a ladder or anything. You can just walk right up to the airplane. There's a couple access latches you just pop open, and this thing is there, and you turn it on. And I'm not going to go through every single one of the buttons that is here. We never use these as flight crew members, so we're not really trained on them, but yeah, just some basic functions there. I'm sure you could probably figure it out just by reading this stuff. But a couple things I wanted to point out to you is just the area down here. And this is what the fueler is using every day when they come out and fuel our airplanes. We will give them a fuel load that dispatch has told us, okay, you need X amount of gas to go out and operate this flight. And they put it into this pre-selected number here. So right now, they've told the fueler you need 12,600 pounds of gas, so 12.6. So they pre-select that number. This is an actual indication about what's actually on board the aircraft in total at this point in time. You can kind of see a breakdown between the left, center, and right tanks here about what exactly is in each one at this moment. But it's really simple. The guy just he hooks up the hose. You put a grounding cable on for static discharge. You pre-select the number, and you just you pull the dead man trigger, and the thing starts pumping. When the plane figures out that you're up to the pre-selected value, it automatically shuts off the fueling valves, and it won't take on any more gas. So it's all a very automated process. It's pretty stone simple. It's hard to screw up. And it's interesting, early in my career, I worked at an FBO, so I did nothing but fueling airplanes for a living there for a while. So if I could do it, it can't be that difficult, I suppose. But just wanted to show you guys a little bit about what that looks like and how it works. One other thing I wanted to talk about also with you guys, as I find it pretty interesting, is the way that the airplane figures out exactly how much gas is on board the airplane in total. And I don't have like a lot of super technical breakdown on this, and you can find this in the maintenance manuals. We once again don't have access to this data in the pilot manuals, but so I don't know how many probes are in each tank to kind of derive this reading. But basically it works off this principle where there's like a metal probe that sticks down into the fuel, and it works off this electrical principle of capacitance, so that like as the little probe is either more or less submerged, the capacitance of the metal changes, and that's calibrated to tell the computers, okay, such and such capacitance equals such and such a value, and it'll feed data in this computer that it basically totals everything up. Another part of the sensing apparatus that resides in each of these tanks is a probe to measure the density of the fuel, because actually, kind of like we touched on earlier, if the fuel is a different density, it correlates to a different gallon amount or pound amount, and this is all some complex conversation that's way over our head for our normal day-to-day operations as pilots. But just if you're curious about how you get a very accurate reading out of each of these tanks, this is how it's done. Interesting also that when you're taxiing the airplane around, for example, or even sometimes you're banking, you'll see these numbers vary a little bit. If you think about what's happening in the wings is the fuel is kind of sloshing around from left to right, and so that the place where that reading is being measured on each probe is changing a little bit. So you'll see like minor fluctuations in here. It's not extreme to the point where you're becoming concerned about something because all of a sudden we're missing 1,000 pounds of gas. But let's say about call it 100 pounds of variance maybe, but you can just kind of see it, that it's there, and you kind of know what's happening. So you're kind of, you're not alarmed by this, but it's just an interesting part of the system to tell you guys about. So one other thing, and kind of the last one that I wanted to talk about before we get into, or come back and talk about the panel and the buttons, that's kind of a simple part, is something that is built into the airplane called a fuel inerting system. So a lot of you out there probably remember there was a horrible disaster back, I think it was in the early 90s, but it was a TWA 800, I believe was the flight number. There was a 747 that had a combustion that occurred in the center tank, and it was supposedly because of some arcing wire or something that caused a spark, because the center tank was empty of most of its fuel, if not all of it, but it just had this kind of residual, like this fuel air like mixture, essentially, like in a fume format that resided in the tank. And supposedly the story goes that this, of course, like as you would imagine, is a very highly flammable type of situation there with this empty tank and this kind of the fume residing in there. The thing exploded, and of course, attributed to a horrible accident that occurred. So I'm not sure about every single airplane that comes off the production lines these days. I'm sure most of them have this, but the Airbus on all their models, they have this, and it's this, once again, it's this fuel inerting system. So it's a way to basically replace that air that would otherwise be oxygen and fuel rich fumes in the tank with this inert gas. So basically the concept is how it works. It intakes air or outside air essentially through the bleed line. It goes through this conditioned service air system, which then goes through an inert gas generation system. So you have this oxygen depleted air that gets put back into the center tanks. The idea is that if there was some kind of spark or something like that, that it wouldn't combust and it wouldn't explode. So a really interesting thing, I think they designed into these airplanes, and a tremendous advancement in safety. Let's say that we're all thankful we have. So now let's come back up to the overhead, and we're going to talk about all the buttons and the lights and everything, and kind of wrap this up today. Back here on the panel, you can see we have the tank pumps here. that correlate to the AC fuel pumps that we kind of hit on earlier in the lesson. We have the Crossfeed button here, and we have the mode selector here. We'll do a lights test here in a second, but just wanted to tell you about which one of these buttons we actually use in our day-to-day, our normal flow of operations. It's really pretty simple. It's only these 6 guys right here, the tank pumps like we said, and those just come on as part of our pre-flight checklist, and they remain on or in the in position for the entire course of the flight, and they get turned off when you're terminating the flight at the gate at the end of the operation. So not a whole lot of interaction that goes on with those after we manipulate them for the first time. One interesting thing that a lot of guys at my carrier do, and I think a lot of others do as well, it's just kind of like a little memory device, is that these switches don't actually technically need to get pushed in until you actually read the checklist. Now when we read the checklist, part of doing that is verifying that we've actually got the fuel on board that the dispatcher had planned. So it's just kind of like a verification step in the process of just like a little mental device. But a lot of guys, like, they won't actually turn the pumps on until we've actually got the fuel in the airplane. This is a really smart idea. It's just one more little reminder that we can use to keep ourselves honest and make sure we're not departing without the right fuel. I know it sounds crazy, but it has happened to crews before, and it'll probably happen again. But there have been cases where flight crews have departed without the right fuel load on, and this is, of course, a very embarrassing situation, because you figure it out really soon after you've taken off, and then you're having to turn back or divert somewhere. It's just really not a professional thing, and something we of course avoid. But just kind of like a little mental device that I wanted to point out to you guys. It's kind of like a real world application. And the other one we use is the Crossfeed button if we get some sort of imbalance. Now most of the time we're flying around, it just happens that the fuel does remain pretty balanced, in our normal stuff that we're doing. If we have an extended period of taxiing, maybe on a single engine or something, when we get airborne, we might be 500, 600, 700 pounds off in the balance sense. So you might use this Crossfeed switch in that sort of scenario when we're out flying around to kind of balance the fuel out. But and then the last one here, the mode select switch, it just always stays pushed in, it always stays in the auto mode. If there was, let's say, like a maintenance deferral that required us to operate it in the manual mode, all those kind of pre-programmed things we talked about before with the sequencing of the fuel and when the pumps come on and off and all this kind of stuff, we would have to do those ourselves. So you could operate the plane in the manual mode, but like I said, most of the time the switch just always stays in. It's always an auto, and that's how we interact with it. And the next one we'll talk about is just, like I said, we'll do a lights test and just kind of, show you, what everything looks like when it's illuminated. So the fault lights, first of all, in the pump switches here, all that this tells us is the fuel pump is delivering not the adequate pressure that the system is designed to deliver. So maybe the pump is still getting powered, but it's not putting out like I said, the right pressure for some reason. You'll show a fault there. So very simply, that's all that means. Of course, the off switch, or the off light rather, is what we'll see when we're at the gate. We don't have these pushed in, and those lights will be illuminated, just telling us, hey, the pumps are in the off position. The fault in the mode selector here just tells us if the automatic mode has failed for some reason. There's all kinds of different inputs, like we said, that could cause this failure. I'm not going to go over every single one, but it just kind of grabs your attention and lets you know that has occurred. And of course the MAN or manual light here, if you did have the push or the switch pushed out of your own doing, it would just tell you that you're in manual mode. And the Crossfeed switch here, very simply, if you press the button in, you get the open light here, which just tells you that Crossfeed valve has opened, and it's just the switch is in the on position, so the light just tells you that. So pretty simple stuff there, not much more to tell you about. I wanted to kind of wrap it up too, to come back and look just a little bit about these the system displays here, and just kind of what some of these symbologies mean. On the top here, we just have the fuel that's been used by each engine. So you've got a pound readout of how much each engine has burned. You've got a total fuel used in the center here. These valves, or these indications right here, are just the low pressure valve switches, or low pressure valves themselves, just the indication to tell you that they're open in this case. The Crossfeed, like we talked about, the pumps here. And if you want to kind of break this down and look or talk about exactly what's happening in each of these situations here. So because all these pump icons are green right here, it means the switch is in the on position. But if you look at the dash in the center tank here and the line in the main tank here, you can see these are oriented in a vertical fashion. These are horizontal. These just mean that the switch is in the on position still, but it's not pumping anything. So there's nothing coming out because obviously all the fuel has been used from the center tank there, and there's no need for the pump to be operating. So it just tells us that, hey, these guys are actually pumping here. These ones are not doing anything. So just a little more breakdown of the symbology there. These values, of course, just tell you how many pounds you've got in each section of the tank that we talked about. And these are fuel temperatures down here. That's all these are. You've got a fuel flow between engines 1 and 2. Tells you how many pounds per minute you're burning. You've got a total fuel on board right here, or fuel remaining, let's say. So most of the time we're flying around, unless there's a problem, we don't have this page up. We look at it like once an hour as part of our normal, just kind of check in to make sure everything's working appropriately. But the one that we're always concerned with and we're looking at the most, it's up on the top of the eCam page here. I can bring it up in the other graphic, which I wanted to kind of point out a few things to you guys and tell you about, and kind of contrast to what we saw before about, here the low pressure fuel valves are closed and these pumps are in the off position, so they're not putting out any pressure. And circling back to one of the first things we talked about, the APU here, you can see the little green indication means that the APU fuel pump itself is actually, operating. It's drawing fuel out of the tanks to run. One other thing too to point out is, this is after a flight. You can see that the fuel has transferred out of the outer tanks there. That's just, the quantity indication here reflects that. And these green triangles here tell us that the fuel is transferred. There's actually also there's a message that'll come up on the eCam that'll say fuel transferred. And we can tell that has happened automatically. So that pretty much wraps it up, I think, for most of the stuff I wanted to tell you guys about the fuel panel, the system, and everything. If you have questions about that, please don't be afraid to chime in. Leave a comment down below. And coming back to the Q&A section here, the next question I wanted to field today is a question from a repeat responder, I guess you'd say, or a dedicated supporter. Once again, from Abai Thomas. He had wrote in a few weeks ago. He had a bunch of great questions, and we fielded most of them in the comments section, but I wanted to point out one portion of his question that he asked. I thought it was a great question. I thought a lot of other people might be wondering it as well. But he asks, can you feel any big difference during single engine taxi? In other words, controlling the aircraft. This is a great question because the handling characteristics of the airplane are altered, of course, when you're taxiing on a single engine. So the steering itself, it actually doesn't feel that much different to when you're taxiing the plane around on 2 engines, but there are a couple things that are changed. Of course, the first one being the obvious is you have physically half of the normal thrust output that you would with 2 engines operating. So we do kind of come into these situations sometimes where there are some airports where you're actually kind of taxiing like up a gradient, if you will, on a taxiway, and you're actually physically needing to move uphill, and you don't have enough thrust in that one engine to get the aircraft moving all the way up the hill. So you find yourself in these situations where you either kind of got to plan ahead because you know the airport so well up to a certain point in time, you kind of know where the uphill sections are at, so you kind of plan your second engine start accordingly. But there are certainly times where you'll find yourself in these places where you're like, shoot, we don't have enough thrust to get up this hill here, so you have to start the second engine, you have to use 2 engines to taxi. And kind of as part of that is, we never use more than 50% N1 during taxi operations, because of course we don't want to damage any aircraft behind us. And around every airport, there's all sorts of ground service vehicles and people working out there, so you never want to be putting out an appreciable or excessive, let's say, amount of thrust, because you could damage things, you could hurt people. So it's kind of one of the things we operate by. So as you can kind of imagine, like I said, there's just these situations where you really do need 2 engines to taxi the aircraft. And to kind of build on that also, as I said in the beginning, the handling characteristics of taxiing a single engine airplane are such that you can't actually make quite as tight of a turn on a single engine in some scenarios. So you have these times where you're pulling into like a back corner of an alleyway. Let's say you're pulling onto a gate, and it's just really tight. You'll always taxi into those situations with two engines because you just have a little bit more maneuverability of the airplane. You can turn a little bit tighter. You don't need as much thrust coming out of any one of the engines. So, in that sense, it does kind of affect the maneuverability of the airplane on the ground. But like I said, I thought it was a great question. And once again, thank you so much for tuning in and participating in the discussions. And like I said, it goes for everybody else out there. If you have any questions, I'll do my best to try to answer them. I really appreciate you guys tuning in. If you like what you saw, just hit the like button or maybe give me a subscribe. I'd appreciate it, and it just kind of keeps me propelling forward with what I'm doing here. So thanks again for watching, guys. Hope you have a great remainder of your week, and we're going to talk again real soon. Bye-bye.